With thousands of transformer models floating on the internet, we can broadly divide them into three types based on the architecture used. First off, we have encoder models. Encoder models use only the encoder of a transformer model. The attention layer can access all the words in the initial stage and is often called auto-encoding model. These models are best suited for tasks requiring an understanding of the full sentence, like sentence classification, name entity recognition, and extractive question answering. Examples of encoders include BERT, Albert, and Electra. Next, we have decoder models. Decoder models only use the decoder of a transformer. Attention layers can only access the words positioned before it in a sentence, and these models are also called autoregressive models. Decoder models are best suited for tasks involving text generation. Examples of decoder models include GPT models as well as CTRL. Next up, and finally, we have sequence-to-sequence models. So these are basically encoder-decoder models which use both parts of the transformer architecture. The attention layer of the encoder can access all the words in the initial sentence, whereas the attention layers of the decoder can only access the words positioned before the current word in the input. These models are best suited for tasks involving generating new sentences based on the given input, such as summarization, translation, or generating question and answering. Examples of sequence-to-sequence model includes BART and T5. Finally, let's discuss the limitations of transformer models. Excluding the fact that transformer models are computationally heavy models, these models are highly biased. This happens because the models are trained on best as well as the worst of what is available on the internet. There is a high chance that these models generate sexist, racist, and homophobic content. Fine-tuning or adjusting the model parameters won't make this bias disappear. To conclude, basically there are three types of transformers based on the architecture, and each one of them perform unique kind of task. All transformer models are biased based on the dataset they are trained in. That's all, folks.